So in this video, we want to look at Descartes' rule of signs. Let p of x, written in descending order or ascending order, be a polynomial function with real coefficients and a non-zero constant term. The number of positive real zeros of p of x is either 1, the same as the number of variations of sign in p of x, or 2, less than a number of variations of signs in p of x by a positive even integer. The number of negative real zeros of p of x is either 3, the same as the number of variations of signs in p of negative x, or 4, less than the number of variations of signs in p of negative x by an even positive integer. A zero of multiplicity m must be counted m times. So let's take a look at an example. Looking at an example should help us understand what Descartes' rule of signs is really telling us. So here is our function. Consider g of x equals 5x to the 6th plus 8x to the 5th minus 3x to the 4th minus 3x plus 1. What does Descartes' rule of signs tell us about A, the number of positive real zeros, B, the number of negative real zeros? So all we're trying to figure out really here is to interpret Descartes' rule of signs. Okay? So Descartes' rule of signs says, first of all, look at how many variations of the sign there is for our polynomial function. Okay? So to determine the positive real zeros, we literally just look at the variations in signs of g of x. Okay? To find the negative real zeros, we look at g of negative x. Okay? So taking a look here, first of all, our polynomial function has to be written in decreasing order. It's also okay to be in increasing order, but normally we just write them in decreasing order, so that's what I'm going to recommend. So here's what we mean by variations in signs. So first of all, look at the 5x to the 6th. The coefficient there is positive, okay? Then we go to the next term, which is 8x to the 5th, which is also positive. So there's no variation in sign. It starts as positive, it stays positive, okay? Then we move to the next term. The coefficient there is negative 3, because we have negative 3x to the 4th. That is a variation in sign. So we're switching from positive to negative. That is one variation in sign. Now going from negative 3x to the 4th to the next term, which is negative 3x, it stays negative. So that's still no variation in sign. So we've switched from positive to negative. That's one variation. We stay negative, so we're still at one variation. But now going from negative 3x to positive 1, or plus 1, we're going from negative to positive. That is a second variation in signs. Okay? So Descartes' rule of signs says we could have possibly two positive real zeros. So we could have two positive real zeros. Okay, that's the most we could possibly have because there were two variations in sign. Or we could have less than 2, but it has to be an even number less than 2. Okay, so if we take 2 minus an even number is 2, 2 minus 2 would be 0. So it's also possible that we could have 0 positive real zeros. Okay? So Descartes' rule of signs says if we have real zeros, now real numbers means it could be rational, could be irrational, but if there's real zeros, there's either going to be 2 or there's going to be none. Okay? Now the same for the negative real zeros, except we've got to figure out what is g of negative x. So the first step here is find g of negative x. So that's going to be 5 times negative x to the 6th plus 8 times negative x to the 5th minus 3 times negative x to the 4th minus 3 times negative x plus 1. So negative x to the 6th power is the same as x to the 6th power. So we have 5x to the 6th power. Negative x to the 5th power is going to be negative x to the 5th power. So this is going to be, when we multiply by 8, it's going to be minus 8x to the 5th power. Negative x to the fourth power is the same as x to the fourth power, so we're going to have minus 3x to the fourth power. Minus 3 times negative x is going to be plus 3x and plus 1. So we have found g of negative x, okay? And so now we need to determine how many variations in sign do we have. So we're starting here with 5x to the 6, which is positive, and then we go to minus or negative 8x to the 5th. That's one variation in sign. Now from negative 8x to the 5th, we go to negative 3x to the 4th. So that stays negative. That's not a variation in sign. Moving on to the next term, it's positive or plus, so we're going from negative to positive. That's our second variation in sign. And then from 3x to 1, we stay positive, so there's not another variation in sign. So there's two variation in signs, okay? So for g of negative x, there were two variations in signs. So we could have two negative real zeros. Just realized I didn't have an S up there. Okay, we could have two negative real zeros, or we could have fewer than two, but it has to be fewer by an even number. So 2 minus 2 would be 0. So we could have 0 negative real zeros. So Descartes' rules of sign tells us that we could have 2 positive real zeros or 0 positive real zeros. We could have 2 negative real zeros, or we could have 0 negative real zeros. Okay? Now, just to make sure that we're clear on this, suppose that we ended up with 5 variations in signs. Okay? Now, we're done with this particular problem. But if we had had 5 variations in signs, then there could have been 5, and let's say that was for the positive real zeros. Then we could have had 5 positive real zeros, or 5 reduced by an even number. So 5 minus 2 would be 3. 3 minus 2 would be 1. So if we had gotten 5 variation in signs on, say, g of x, then we could have had 5 positive zeros, 3 positive zeros, or 1 positive zero. It would have to be one of those, okay? In the same way, when we found g of negative x, suppose we had gotten, say, 8 variations in sign. Then there could have been 8, or 8 minus 2 would be 6, or 6 minus 2 would be 4, or 4 minus 2 would be 2, or 2 minus 2 would be 0. So there could have been 8, or 6, or 4, or 2, or 0 negative real zeros if g of negative x had had 8 variations in signs. Okay? So this is the idea of what Descartes' rule of signs means.